Now let us understand the effect of common ion effect on the solubility of the salts. The example can be explained by giving a numerical. It's like find the solubility of lead sulfide in 0.01 molar sodium sulfide solution. See, this solution is already having sodium sulfide, and in this what will be the solubility of lead sulfide? Ksp of lead sulfide is given to us. From this Ksp we can find out the solubility will be 10 to the power minus 4 because it will be the square root of this. But now in the presence of the sodium sulfide it will become somehow less than this. How? Let us see this. See, when we will say the Ksp, it will be of course lead ions concentration and the sulfide ions concentration. But when I will say 10 to the power minus 8 and it will be S, I will put this S solubility of the lead sulfide from this one, but definitely I will put this sulfide ion from the sodium sulfide also, which is already there in the solution, which is 10 to the power minus 2 molar. So let us solve this. It will become S square plus 10 to the power minus 2S. This is neglected because this will be very small. So it will be 10 to the power minus 8 by 10 to the power minus 2. It will be 10 to the power minus 6. So let us see this now. This S is far less than the normal one, because from here we can know this solubility could have been 10 to the power minus 4. So this is what is the effect of common ion effectors on the solubility of these salts when they are taken in the presence of another solution, both having common ions.